find this. This is nothing else but s prime. So this is 2t minus 1/2, because the derivative of this is negative 1/2 and the derivative of this is 0. To determine the acceleration, we differentiate the velocity, or basically we differentiate the distance twice. So the derivative of this is 2. So in part C, they want us to determine v of 1 and a of 1. So v of 1 will be 2 minus 1/2, which is 3/2. Or if you want to write it as 1.5, that's fine too. But you have to write meters per second. So if the distance is measured in meters and the time in seconds, then the velocity will be meters per second. Now a of 1, there is nothing I can do here. It's a constant. So this will be 2. But remember, it's the velocity with respect to time. So this is the measurement unit of the velocity. So the top is meters per second, and the denominator is time. That's why the measurement unit for acceleration is 2 meters per second squared. Remember, they have to be different. This is the derivative of the distance, and this is the derivative of the velocity. So the measurement units are different.
Thank you.
Thank you. Other questions from my lab math, from homework, from class, from anything?
Can we do number 40 on page 154?
40 on 154?
Yes.
Okay, very good. 154, you say. 154. 140, 130, 153, 154, 40. Okay, 40. I see. So this is y equals the square root of x plus 4 divided by the cube root of x minus 5. What do they want? Differentiate. Okay. That's another cumbersome situation. Not a nice one. Okay, in order to differentiate something like this, I have to use the quotient rule. I have no choice. So then y prime will be, I can write this in the denominator, squared, and forget about it. Then I have to differentiate the numerator. And I have to remember something that we discovered together. The derivative of this is 1 over 2 the square root of x. The derivative of a constant is 0. Multiplied by, so this was the top, prime is this. Multiplied by the denominator, which is the cube root of x minus 5. Don't forget minus. Copy the top. And now I have to differentiate this. When I differentiate negative 5, I get 0. But how do I differentiate this? As we showed today again from the very beginning of the class. X to 1/3 prime. Bring down 1/3, subtract 1 from the power, and we get negative 2/3. So this is what I have to write here. Not a nice function. And no, I don't want you to do anything to it. That's it. And please do not attempt to simplify anything. The reason, if these were the same indices, index 2, or index 3, I would try to attempt, a simplification. But no, when we have this kind of power, then I have to change in order to multiply these two. If I want to multiply the square root of x by x to negative 2/3, I have to change this into x to 1/2 and then subtract 2/3. And it will take half an hour. So if they were the same index, yes, I would have said, okay, let's attempt. But this is fine. That's good enough. Good. Other questions? It was a very good question. All of them were very good. Anything else you would like to review? Also, let me ask you this question. Is there a particular type of problem that you would say, oh, I think if I see it on the test, I may have some difficulties with it, or just say, I want to see it again. Is there any type of problem that you would like to go back to? Anything?
Piecewise functions. I know, just one more problem and just getting it done on paper now, and I think I'll be good.
Yes, my pleasure. I'm trying to be funny. Sometimes I succeed, many times I don't. I know. Can you find one for us, please? Anything. Anyone that you want to work on. Any function. You can make one up. Any function that you want to work on.
This one's a little bit of an older one, but it's one we've done before, but it's in front of me. So
it doesn't matter. Any problem.
Okay, x squared if x is less than 0. -3 if x is equal to 0. And -2x plus 3 if x is larger than 0.
Excellent. Perfect example. So I immediately changed this into -infinity to 0, right? And I immediately changed this into 0 to infinity because my first step has to be the domain. If I don't determine the domain, then I will not know what is going on here. And where do I pick x values? So I have this, and I have this. So what do I do? What is the domain? Ready?
Real numbers.
All real numbers. Very good. Of course, this is a key number. It has to be in the table. So when x is 0, the function is -3. And then also look at these parentheses. They will touch -3, but they will not touch one another. Then I make sure that I don't make a mistake, and to the left of 0, I have to graph a quadratic function, and to the right of 0, I have to graph a linear function. I need at least, a couple of points here for a quadratic and at least one more here. But first I'm going to just plug in this value because I need a number here and I need a number here. When I plug in 0, I get 0. When I plug in 0, I get 3. So now I continue with some other numbers. Let's say -2 and -1. When I plug it in, I get 1. When I plug it in, I get 4. Now on the other side, I'm going to say 1. And 1 times -2 plus 3 will be also 1. When this is 0, it will be 1.5. So I'm going to put 1.5 in here because that's an x-intercept. And that's all I need. So now just remember, there are 3 different pieces. So I'm going to use 3 different colors. I have a red, I have brown, and I have purple. The quadratic function will be red. This point will be brown. And the linear function will be purple. Okay, so here's the coordinate system. So now, red. 0, 0 is an open point. -1, 1. -2, 4. I know how to graph. This is quadratic. I don't need another point. It's good enough. I'm done. Now, this point 0, -3 is the second branch of the function. So I decided to use brown. So this will be here, and it has to be a full point. That's the -3. Done with the middle. So now purple. I have 0, 3, which has to be an open point. You cannot have more than one full point, obviously. And then 1, 1, and then 1.5 on the x-axis. The range of this function is anywhere from -infinity to +infinity. So always remember, please, for me, do not extend the quadratic function to this side. Do not extend the linear function to that side. That's not a function. But now this is by vertical line test is a function. Good. It was a good pick. Thank you. Next question. Anyone?
Thank you.
Before we move on, why is it that you can only have one full point?
Very good question. If I fill this in, this is no longer a function by the vertical line test.
Oh, okay. Thank you.
So that's what we said, right? So that's why if I continue here and I have something like this, I can't look at it. I can't give any credit for it. Why? By the vertical line test, this is not a function.
Okay, that makes sense. Thank you.
Thank you. That's why I use 3 different colors. They cannot overlap. The blue cannot go over red, and vice versa. Good. Next question, please. Anything? Anything else? Okay, so many questions. How many questions are on the test? 10, 12, something like that. I see the question, sorry. I just saw it. Okay, I want to go back to, where is my course? Okay, got it. I want to go to modules. And then I want to share. Where are you guys? I can see you. Okay, now I can. Okay. So right here at the very top, maybe I created it already. No, I did not. Right here at the very top, you will have a module entitled, but I did post an old test, didn't I? Oh, here it is, yes. So I'm going to move this to the very top so it's easy to find. Okay, so right here, you're going to have another assignment in which you will upload like a regular assignment, like written homework, right? So where you will upload your work. So let's take a look at this and see if anything catches our eye. And please, before I say anything else, if you're asked to find the derivative using the definition, you have to use the definition. So I'm going to stop sharing for a second. So if you are, I'm on page 5. So if you're asked to find f prime of x, do not write f of x plus h minus f of x divided by h. It's incorrect. You have to have the limit as h approaches 0. If you omit this part, then I cannot look at that. Please, I'm begging you. Okay. So this is a rational function, and you're asked to just simply, you're not asked to find the derivative. You're asked to find the difference quotient and evaluate it. Here we just looked at the problem, and here you will be graphing this and then answering some limits questions. This is a very simple problem with the cost, revenue, and profit, and the break-even point. Here you're asked to find the domain of this function and present it in interval notation. Find the average rate of change. Can anyone remind us what is the formula for the average rate of change of a function?